Hi, my name's J Patterson, and this is the fifth of a series of lectures introducing XML and some of the ways in which it's formed and some of the ways it's used. And in this final lecture in this sequence, I'd like to talk a little bit about XML schemas. XML schemas are not a very widely used aspect of XML, but it's interesting and it's something that you should be aware exists if you're working with XML. Let's dig into it a little bit. Some key points I'd like you to take away from this lecture are that XML is a well-studied and well-researched data format. There are a lot of tools that are built to help manipulate XML data, and many of these technologies apply a schema to generic, well-formed XML to create a standard language for describing a particular kind of data. In our discussion of XML, we've been looking at XML in several different ways. We've been looking at the file structure, the character encoding. We've looked at the tag structure, and today we're going to look, or this lecture, we're going to look at the schema structure. One kind of schema that you can use in XML is called a DTD. The DTD stands for a document type definition. The DTD specifies when a well-formed XML document, for example, a document with one root and nested tags, tags that match the beginning and the end, attributes that are quoted, special characters that are escaped. That makes it a well-formed XML document. To make it a valid XML document, it has to conform to some schema, and a DTD can be one of the schemas that it conforms to. What does it mean to conform to a DTD? Well, a DTD is going to restrict what tags can be present in an XML document. It can restrict what attributes can be present on those tags in the document. And it can also restrict the order and the values that the tags and attributes can have. So it restricts the tags themselves, which ones you can have, and it restricts the structure. When do you use a DTD? Well, you don't have to use a DTD. DTDs are optional. What they really are is they're kind of like us. They're in the same way that a spell checker in a written document checks to make sure that you've spelled everything correctly. A DTD checks to make sure that you've structured an XML document correctly. It helps you to check if your XML document has any mistakes. And there are tools that will take your document and a DTD and tell you whether or not they match. So for example, if you want to check if your XML document is a valid podcast feed, you could ask one of these programs to check it against an RSS DTD. Do you want to make sure your XML is a well-formed and valid user interface spec? Well, you could compare it to a XAML DTD. DTDs are documents as well. They use a different language than XML. It's not very complicated, but it's hard to parse the first time you see it. And the DTD can itself be in the XML document. So you can start your XML document with a template of how it needs to be written in the tags that follow. Or the DTD can be in a separate document, and you can, if you want, optionally have the XML have a link in it pointing to where that DTD can be found. Let's take a look at the previous example that we had of a cookbook. And what I've done is I've restructured it a little bit. I've changed the names of the tags and I've moved the attributes around. So for example, now our root tag is called book, and I've added attributes of type, title, and author. Type being cookbook, title, cooking with XML, and the author, J Patterson. The children of the book are called sections. They have titles as well. This section is called salads, so the title is salads. And I've changed it. The tag is section, and the attribute is title, and salads is the value of the attribute. I've changed what the children of sections are. I've made things that are recipes, and a recipe has a title and a diet type, ingredients and directions. And you can see that I've also changed some of the capitalization. I've made this XML document closer to what you're going to see in real data structures. So our salads have been restructured like this. Our soups have been restructured like this. Similar, just with the data that we had before. And finally, our desserts have been restructured as well. Section called desserts, 2 recipes, ingredients, and directions. Now, how do I know that I put all the different components in this book that I intended to? For example, let's say that I'm a publisher, and maybe I have a catalog of hundreds or thousands of books. Each of those books has its own XML document that describes it. Well, how in the world can I efficiently go through and make sure that all of my XML is well formed? But on top of that, how can I make sure that, for example, all of the books have a title, or that all of the books have an author listed, or that all of the directions have prep times? Or do I even need that? You can do that with a DTD. So let's look at how you could structure a DTD in order to enforce some rules. This is an example of a DTD. This text can be embedded at the top of the XML document after the second line, after the first XML declaration. And you can see there's a couple different components here. First of all is doc type. That just sort of describes what the name for the DTD. Then you can see there are these exclamation mark element tags. Element, 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 element. These describe all of the valid nodes that are allowed to be in your document. So by reading this, I can see that I'm allowed to have nodes in my document that are book, section, recipe, title, diet, ingredients, and direction. From that alone, I know what nodes are valid. That tells me what tags are valid in my document. What follows each one of those tags in the element declaration is a small language describing what kind of children you can have. So the way that you read this is the book tag is allowed to have section tags as children and nothing else. By putting it in parentheses with a plus sign there, we're saying that every book has to have at least one and maybe more. That's what the plus sign means. Then you can see that the section tag, it follows. Section tags are only allowed to have one kind of child, the recipe child. And every section must have at least one recipe, but maybe many more. Again, the plus. The recipes are a little bit more complicated. If you look at this, you can see that there's a sort of more elaborate structure to what is allowed in a recipe. What we see is that it can have a title, followed by a diet, followed by ingredients, and followed by directions. In fact, what this means is that it must have a title, it must have ingredients, and it must have directions, and they must come in that order. What's interesting here is that the diet tag has a star and some parentheses around it. This structure means that diet is optional, and there may be more than one. So it would be valid to have title, ingredients, and directions as children and no diet tag, or it'd be valid to have title, diet, ingredients, directions, one diet tag, or it would be valid to have title, diet, 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 ingredients, and directions, multiple diet tags. That's what that particular structure allows. The title tag is only allowed to have data as a child. It's not allowed to have any nodes as children. That's what the hashtag PCData means. Diet is only allowed to have data as its child. Ingredients can only have data as its child. Directions can only have data as its child. Then we get to a separate definition, the ATT list. This describes what attributes each tag is allowed to have. So a book tag is allowed to have a type, and it can take on one of 3 different values: cookbook, novel, or textbook. Can't have any other values. Those are the only 3 that are allowed. And furthermore, this attribute is required whenever you have a book tag. In the second case, I'm describing a different attribute, title. A book may have a title tag as well. The title value can be any kind of data. That's what the C data here means. But it is required. So it's free. The assignment, the value, the data can be anything you want instead of just cookbook, novel, and textbook. But you have to have it. Likewise, a book has to have an author. It can be any data you want, but it is also required. Section has to have a title. It can be any data you want, but it is required. Diet has a different option. Diet can have an attribute tag. Diet can have a type tag, and if it does, it can have any value it wants. That's what CData means. And the hashtag implied means that it is optional. It doesn't have to be there. The type attribute doesn't have to be there. Finally, we can see that directions has a prep time tag. It can have any text that you want, and it is also optional, which is what implied means. So now let's look at whether or not this document matches that. We can see that there is the root book. Let's take a look. Book tag. It has 3 attributes, type, title, and author. If we look back up in the DTD, we can see that books are allowed to have type, title, and author. Type is a cookbook, so that's good. So it looks like book is going to pass, provided that it is well formed and has a closing tag. Section is allowed to have a title. In fact, it's required to have a title attribute. Book has section as a child. That's allowed with the element tags. Section has a recipe as a child. That's allowed looking at the element in the DTD, the element description of the DTD. Recipe doesn't have any attributes, and that's okay because none are defined. A recipe then has a title. Well, that's allowed in the definition. It has a diet. It has 1, so that's okay. Diet has an attribute of type. That's optional, but it's okay. It says vegan. Ingredients follows, so recipes are allowed to have ingredients nodes, but ingredient nodes are only allowed to have data as children, and that it does. And finally, the directions tag. The directions tag is allowed to be a child of recipe, has to be the last child of recipe. It has an optional prep time attribute, which can have any data that we want. And then finally, the child of directions must be data, can't be another node. The second recipe for noodle salad, scanning that real quick, looks pretty good. We see our first section is closed, and we get to our second section. Sections followed by sections are okay as a child of books. Has a title, 2 recipes, those all look well formed. Finally, we have a third section, desserts. 2 recipes, title, ingredients, prep times, looks well formed. Finally, we get to the bottom and we close all of our tags in a nested structure. This looks like well-formed and valid XML. Valid because it matches a DTD. These can get pretty complicated pretty quickly. So here's an example of one particular website that will do online validation of whether your XML is well-formed and whether or not it conforms to a DTD. If you're interested in finding such a tool, I'll put the URL for this in a follow-on slide. But you do have to be careful because there are a lot of XML validators out there that don't check DTDs, that just check whether XML is well-formed, but doesn't check whether it matches a DTD. Also, just be slightly aware that if you're going to put your XML into an online validation checker, you are giving your data to a web service. And so make sure that it's not sensitive data that you're asking to be validated. So in this example, I'm going to select DTD and I'm going to choose the file on the right to have validated. I'm going to see what it says. It says there's a problem at line 81. I introduced some errors. And there's a problem at line 84. If we go over to the document on the right and we swing down to line 81, we can see that, directions doesn't have a prep time. Looks like it's required according to the DTD at the top. Must have changed that. And then let's run it again. What do we get? Still a problem. We've got a problem on line 84 that for some reason we have a problem with our recipe tag. It's missing a title. So let's add the title in, baklava. I intentionally introduce an error here by misspelling the closed title tag. That's not an error with DTD, it's an error with well-formedness. But a tool like this can check both of them. So we'll enter it in, load it up again. We'll see that title tag has to be closed. Go over to our document, fix that up, save it, and then rerun our DTD checker, and everything should pass okay. Looks pretty good. Validation successful. It's great to have a tool that can help me make sure that my data is well formed, because if I have thousands of books, I would like to be able to run this tool in a kind of an automated way to just check that all of my cookbooks, all of my books in my publisher catalog are well formed and valid. XML and HTML have had a rocky relationship. They kind of co-evolved together. XML has its roots in the academic community, and HTML has its roots in the startup community, in the web application community, in the browser community, in the search engine community. And these two communities move in different ways and have different concerns. But both communities recognize that they were kind of working on similar sorts of documents. And so a move was made by the standards body, the W3C, to try and coordinate a merging of the two into HTML and XML so that both of them would be one standard called XHTML. And as the Venn diagrams show, it would be that XHTML are those documents that are both XHTML compliant and well-formed XML and valid HTML. And from this, you can probably imagine that there could be a DTD that has all the rules of HTML written into it. That DTD could be pretty long, but it could check all of your XHTML documents to make sure that it's valid HTML. And then an XML checker could make sure that it is well-formed XML. And so there's a nice set of tools here that would provide this kind of unification and standardization. Unfortunately, this standardization took way too long. And the people who were in the practitioner world, the people who were running businesses, insisted on moving forward with tags and structures that were working in browsers today in order to make progress, particularly on HTML5. And so as HTML5 went forward, HTML5 respects XML well-formedness. So if you put well-formed HTML in all of your documents, you're safe. And I recommend doing that. I recommend that whenever you have your tags, you always open and close them, that you nest them, that you use attributes and styling appropriately. But in some cases, it's not strictly necessary. And HTML5 allows for some of those variations from well-formed XML. Now moving on, what goes beyond schema? In the beginning, I said we had files, characters, tags, and schemas. Is there anything else you can do with XML? Well, in fact, there is. There's quite a bit of things that you can do with XML. Some of the interesting things we've looked at, for example, you can do validation of XML, both well-formedness and whether or not it's valid according to a DTD. You can do that with an online tool, like the URL that we looked at in this lecture listed there, or you can do it with an offline tool. You can download various kinds of command line programs and local programs that will do the same work that the online tools will do without going out to the internet. There are also other kinds of schemas besides DTDs. There's one called Xslt, for example. It doesn't have to look like our DTD. One of the more interesting kinds of things that you can do with XML is called Xslt. This is a transformation language, and I'll be honest, for about 6 months when I was at grad school, I got lost down a rabbit hole of trying to understand Xslt in greater depth. Basically, if you can imagine this, Xslt is a tool that helps you transform any arbitrary XML into an HTML document. So for example, that message screenshot we had of XML, transforming that into well-formed HTML. That seems like maybe it's not too hard, that you could write some kind of program that would transform an XML document into an HTML document in the way that you would like, taking the data and making it sort of a presentation. The thing that's kind of crazy is that Xslt is a program that transforms XML to HTML. That's not the crazy part. The crazy part is that Xslt is also XML. So it's a program written in XML that transforms XML into a different kind of XML or HTML. So three XML files, your input, your program, and your output. But then what gets really crazy is when you run Xslt programs on themselves. So the program transforms itself into a different program. That's just sort of scratching the surface of the kinds of things that are capable in XML that get into some of the academic and interesting sorts of theoretical components about structured data that you can dig into more deeply if you find yourself interested. Yeah. So key points in this lecture. XML is a well-studied and well-researched data format coming from the academic community. And there are lots of tools that are built to manipulate XML data. For example, schema checkers. Many technologies will apply a schema to generic XML to allow you to create a standard language defined by your DTD so that you can describe a particular kind of data. A DTD that will tell you whether your XML is an RSS feed, or an XAML document, or a WSDL document, or an HTML document. I hope this helps open your horizon, open your eyes, broaden your horizon about the kinds of things that are possible when you have well-structured data in an XML format. And I hope you take away from this the value of making sure your HTML is also well-formed XML. Thank you for your attention.